Did you know something new is invented every 10 minutes? Join us as we speak to the innovators reinventing our world here on planet Earth and far, far beyond. Welcome to GTWN Now, a podcast brought to you by the Global Telecom Women's Network and sponsored by CMS Global. GTWN Now introduces the movers and the makers at the cutting edge of technology who are committed to keeping us all connected. In each episode, we invite a leading expert to share her experience building life-changing inventions in places and spaces that don't yet exist, and the inspiration they must muster to tackle the impossible. We also ask our guests to share tips, tools, and strategies to reach your own moonshot. I'm your host, Rosali Gitau, founder of Bixi FinTech for Women and Global Telecom Women's Network International Board member. Welcome to GTWN Now.
Hi, my name is Sheena Jacob, and I'm a partner at CMS based in Singapore. And today, with my colleague, we're going to talk to you about quantum.
Hi, I'm Lisa McClory, and I'm of counsel in CMS London. I focus on deep technology and really looking forward to this session today where we can explore what quantum is and the relevance of recent policy developments for boards and companies.
Thank you, Lisa. So it's such an exciting topic, quantum, because it's so new and interesting, but it's also really very technical. And so could I ask you, Lisa, because you're a real technical expert, to just give us a very brief explanation of what exactly is quantum technology?
Quantum science is really essentially the application of quantum physics into technology. It's the science of how tiny particles work and how you can apply those in computing approaches to create radical new ways of detecting changes in networks and enhance the power of supercomputers. Essentially, quantum particles have unique properties such as entanglement, where one particle can affect another over any distance. And this can be used in, say, a quantum network to detect whether or not a communication has been observed. Particles change upon observation, and whether or not there has been any change to data over vast distances. So really, quantum at the moment is moving from research to commercialization. There are three aspects of the technology. We think about quantum computing, which often relies on tiny particles within computing systems that can process data using this property of entanglement. They are often described as perhaps they use cooling systems, so they look a bit like chandeliers or jellyfish, sometimes people say. And they're often located in data centers. They require a lot of infrastructure. We talk about quantum sensors as well. And then lastly, quantum networks that allow for the exchange. So two quantum processors talk to each other to exchange data over distance.
Thank you, Lisa. That's very, very helpful. And maybe I can just discuss the first technology that we were talking about, which is, quantum computing, which I think is the one that most people might be familiar with. So what exactly is quantum computing? I think based on what you've explained in terms of how quantum technology works, this is a different form of computing. It's much more powerful in some ways because it's not processing in a linear fashion, but it can actually process different streams of data at the same time. And so it has lots of different ways in which it's able to process the data and therefore actually be a lot faster than the traditional computing models, which we've been used to. I think what we're also seeing is that obviously with AI, quantum is just going to boost AI technology and enable AI capabilities to actually accelerate. So I think that's also very interesting. At the same time, we do think that quantum computers will also work alongside other computers. They generally don't work alone, but when they work alongside perhaps a supercomputer, it will really provide a much more powerful overall system for many use cases, which maybe we can talk about in a little while.
Thank you. I think it's really interesting to think about what use cases these new systems can be put to, and really that as we're moving from a research phase, and traditional universities have thought about what applications these computers can be put to. If you're working within a business, Sheena, what do you think are the implications? Why should a board or a general counsel think about this, and why now?
It's a great question, Lisa. I think in terms of, I guess one of the risks that people talk about when we're discussing quantum is the risk to traditional encryption. And so what we are seeing is that there is an anticipation that at a certain point in the future, let's call that Q-Day, that quantum computers will be able to break existing cryptography that we are currently relying on. For example, to have public-private keys. The financial system uses encryption technology, and we use that quite widely across many different sectors and industries. And so because it involves cryptography and algorithms that are quite powerful, the idea is that a quantum computer or quantum computing would actually enable someone to break that encryption, because the technology is going to be so much more powerful. We don't really know when that day is going to be. So Q-Day is estimated to be anywhere from sort of 2035 to 2039 or so. But I think there is a general consensus that it is likely that, based at least on the existing technology that has been used for encryption, that quantum computing and quantum computers will get to the point where they will break this encryption. And of course, that Q-Day, could also be translated into D-Day for a lot of businesses and boards, general counsel, thinking about how they're going to prepare for this significant risk, because all the data, all the systems that they're using could potentially be at risk. And I think that is something that boards need to be really cognizant of. It's a problem for today, because it'll be too late by the time that happens to try to transfer the data or migrate the data into a different system. So that's something that has to be tackled now. On top of that, Lisa, you might have heard of this concept of harvest now, decrypt later. That's something that we are seeing. And the idea behind it is that right now, when you actually harvest data, whether it's through cyber attacks, ransomware, etc., often the very sensitive data is encrypted. And so it can't be used by the criminals or threat actors. And in fact, it's not even treated as personal data because it's encrypted. But considering the fact that if some of this data retains its value, and it can be decrypted in the future, there is the potential that that data is going to be exposed at a future date. So the fact that your data is encrypted when it is stolen is not necessarily going to be a risk mitigation in the future if that encryption can actually be decrypted. And so that is a real threat that is going to face companies, and particularly we're seeing financial institutions looking at this, and financial regulators are extremely concerned, obviously, because this is a significant risk. And financial institutions, as well as their supply chains, are going to have to step up and consider how they're going to adapt their systems, their technologies, in order to manage this quite significant risk.
Right, that makes sense. And that sounds very concerning if a lot of our existing infrastructure depends on classical encryption methodologies, and there could be some risk to that. Just digging a little bit deeper into what that means for organizations that were reliant on classical encryption. I guess the old way of doing this would have been to have a multiplication or really hard maths that traditional computers wouldn't be able to solve. And the shift that we're seeing with quantum computing is that with the properties that we were talking about of entanglement and superposition, quantum computers can effectively try all of the different sums at once. So they can easily find which prime number was used to multiply to get a key in classical encryption. New approaches developed by NIST are starting to provide solutions to businesses, and we're starting to see new standards emerging. But really, I think it's early days, and it's not always easy for organizations to know where their data risks are and what kind of encryption they require going forward to protect themselves adequately. So I wondered if we might talk about perhaps some of the policy drivers and standards that we're seeing help financial institutions to find a way through all of this complexity. Sheena, have you seen anything that might help?
I mean, I think so. Policies are really, there is a global race, I think, right now for quantum supremacy, like the space race. And I think, very similarly, what is driving industrialization across the three main quantum technologies that we have been talking about. And so that's sensing, which is the use of sensors, which have multiple applications, quantum computing, which we talked about as well, and of course quantum networks. And maybe, Lisa, could you tell us a little bit more about quantum networks before we sort of go a little bit further to see how this is affecting business?
Quantum networks is a very quantum networks are emerging around the world as a way to really protect data whilst it's being transferred. I think when we were talking before about how there is this risk to organizations of harvest now, decrypt later, there tends to be a global split on how to best protect information as it's being transferred. We know that this can happen on an organizational basis, but also that nation states do gather data on each other. Some data may become less valuable over time, but clearly the issue is that you need to protect, say, valuable patent or IP rights or information that may need to be may retain its value longer term. So networks are emerging as a solution to that. The way that they work basically is to have two physically separated quantum processors that talk to each other and exchange quantum states. What this allows an organization to do is know whether or not someone's tried to interfere with the data in transit. And there are other applications further down the line. Currently, a lot of the innovation is focused on quantum key exchange. So basically allowing the two processors to affect a handshake, and so that person A can know that person B has got the same key as them, and that they're both corresponding with each other and not with an unauthorized third party. These rely on large fiber optic cables and also satellite laser links, because one of the issues is the quantum technology is quite fragile at the moment, doesn't necessarily travel over longer distances. So we're seeing this really interesting integration with space technology as well, and the use of satellites to replace traditional relay systems within networks. And then, so moving on beyond sort of pure quantum key exchange, the potential really for quantum networks is to create these really powerful quantum computing networks that effectively make up a giant, powerful processor across a totally secure network, effectively kind of the future of the internet.
Sounds really exciting. And I think because of these developments, I think governments and organizations are actually looking at, how these problems are going to be tackled, how these risks are going to be mitigated, and also how to protect national security. And so we've seen a number of organizations and governments look at quantum. In just early this year, we had the G7 Cyber Expert Group formalized, that financial services industry must treat PQC migration as a systemic risk, and that this is not just an IT problem. It really needs to be considered by the board. So I think that's, that statement actually demonstrates, how important this is from a policy perspective. And I think we're seeing that around the world, perhaps, as well. Is there, and, I think in the US.
Yeah, absolutely. I mean, I think regulators, it's seen as increasingly this is a systemic threat, isn't it? But so there needs to be a coordinated approach, and that is what we're often seeing from national policy makers. There's been a date of 2035 that's been shared across the UK National Cybersecurity Agency, in the US, and also by the G7 Cyber Expert Group, so pushing organizations to work towards this 2035 date for quantum readiness, and really encouraging a coordinated approach to quantum migration. As whilst we want to protect against risks, obviously we also need systems to be compatible. There is this interconnection of hardware and software, and standards are what join all of that up. So we have seen in the UK lots of focus on planning from financial regulators as well, recognizing that financial services organizations rely extensively on technology and are interconnected with each other too. So it's not just a risk that's unique to any single organization. In the US, there's been a proposal to extend the National Quantum Initiative for 5 years. This is adding NASA into the quantum mandate, so further building this interlinking with space-based quantum networking. And there's a high degree of connectivity also with defense technologies as well. This is a very big national imperative to ensure that in the EU and elsewhere, nation states protect their access to quantum chips and ensure that they can rely on secure networking and communications for defense. Sheena, have you, so in terms of industry, we're talking more about financial services. What sort of steps are you seeing people take at the moment? What are the key sort of innovations that you think are interesting in this area?
Yeah, I think we're already seeing financial regulators step in and impose requirements. So, for example, you have the requirement to use, encryption across your systems and consider whether or not these are quantum proof or at least quantum ready. To the extent that they can be. And I think that is one of the challenges, because you're trying to prepare for technology that technically is not really fully developed. And so, but it is possible to move forwards. And in Singapore, the financial regulator in collaboration with various financial institutions as well as network providers, has actually completed a proof of concept sandbox to evaluate the use of quantum key distribution for secure communication, specifically for the financial sector. So I think that was quite interesting to see that it's actually completed that sandbox, and it's also issued guidelines requiring financial institutions to take certain steps, and we are seeing that replicated across countries. So this is just an example, but I think apart from financial services, which I think we've talked about for quite a bit, but there are other sectors and industries that are also quite impacted by the quantum technology. And Lisa, can you discuss or some of those?
Yeah, I think it's there's such a broad range of applications. Obviously, quantum is a powerful computer. It can integrate with other supercomputers and really accelerate AI-driven discovery tools across mostly every area of industry. So we're seeing in the UK, the National Quantum Computing Centre has made available 12 quantum computers to researchers on an open access basis so that they can explore these new impacts in healthcare, pharma, and also new approaches to AI that can allow us to make different kinds of discovery that are out of reach of current AI systems. So I've heard people say that quantum lets us look up into the sky and down into the earth. Really, that just means that there's all of this natural data, like climate data, that is just too far beyond existing computing approaches, and that may mean that we can make game-changing innovations in many more sectors. Thinking about healthcare and pharma and particular applications, drug discovery and research is an important area. And we've seen a collaboration between IonQ with AstraZeneca and AWS and NVIDIA, providing computational chemistry. Clearly, in this area, data security is also of major importance. So healthcare organizations are exploring both the innovative potential of quantum computing to accelerate research, whilst also looking at how do they protect sensitive healthcare data from quantum risk. But also in the context of navigation, BAE aircraft have recently deployed a quantum-based navigation system that's jam-proof, using quantum science to make new approaches to quantum sensors. And this embarked on recently a commercial flight trial. On top of that, I think, Sheena, there have been some developments in Asia, haven't there, around quantum networking, where that's seen as important to have this sort of physical hardware.
Yeah, so I think the focus in Asia actually has been on the hardware in terms of communication, so not just the mathematical algorithm problems, but actually building and looking at developing QKD networks that would actually be secure. And China has been spending a lot of money and has already developed a very, a long terrestrial QKD network. And so we currently are looking at it's called the Beijing-Shanghai backbone. And the intention is actually to develop this network by 2035. And that will actually be implemented and enable communications across, a secure network. And I think we're also seeing other countries in Asia go down that route and look at the infrastructure, which I think is going to be very important for certain sectors, because certainly for, communications underpin, I think, a lot of what we were talking about just now. And perhaps it is, I think, going to be a real game changer for the telecoms industry.
Absolutely. And I think one of the other requirements will be for a lot more data. Again, we we'll see data centers having this opportunity to invest in the infrastructure that will allow us to access potentially different computational approaches, may solve some of the challenges around data processing and energy that the AI has presented. Recently, there's been launch of a responsible quantum computing framework through the UK National Quantum Computing Centre that focuses on many of the areas that we're familiar with from AI. How do we make this technology safe and secure and reliable? Never easy when the technology itself is so complex. And we're presented with the same sort of black box problem, but they are obviously focusing as well on how do you measure safety, I guess, and also how do you understand the climatic and environmental impact of quantum technologies? Where could that perhaps present innovations that help us to solve the data and water challenges of AI technology? So, and at the heart of this, really, there is a lot of focus on smart data, and I wondered if that's something that you've come across in Asia to some extent, Sheena. I know there've been.
Yeah, I mean, I think we've all been talking about AI. It has been, I guess, AI was the hot topic, I think, in 2025, and I think looking at smart data. It is really a huge transition and really accelerating the adoption and implementation of AI. And I think AI regulation and looking at smart data is something that will be very important because we need to understand what are the opportunities provided by smart data and what are the risks that it entails, especially when we're talking about quantum and the potential for the decryption, right? What do we mean by smart data? I think that's something worth talking about. And really, obviously, it's not just big data. Currently, we are talking about very high quality data that is also structured. And that is obtained from the sensors that we were talking about as well. So if we have lots of sensors collecting data in real time, and if it is well structured, then we have very useful high quality data that can be used for a number of technologies and also, for a number of solutions that I think currently we are still unable to fully deploy. So I do think that there is a connection between smart data and quantum. And, Lisa, I think it might be interesting to find out your thoughts on, what is this link that we're talking about between smart data and quantum.
Yeah, I think that so data is the foundation of all of this these new technologies, and we're seeing increasing convergence of quantum AI and other essentially advanced data-driven technologies, including sensors, Internet of Things, even robotics. Requires powerful processors that can understand real-world data and use LLM innovations, large language model innovations, to train robotic behaviors. So we have to see data as an asset increasingly in a way that organizations haven't in the past. Data was just something that maybe that happened and that the organizations may be sitting on lots of information that has unrecognized value and also risk. So when we think about that in the context of quantum, what it tells us is that organizations need to perhaps replan their data strategy around these new technologies in a time of change. And I suppose governments have recognized that too, and recognized the importance that high quality structured and contextual data represents to organizations. And they've tried to solve that in a way that enhances competition and protects against risk by creating these smart data frameworks. So in the UK, this started with open banking. Open banking is a way that within a regulated setting, consumers can consensually share their data, and that allows data to be unlocked from data custodians. So banks may be trusted sources of consumer data, but they can make that available to innovative new applications that might provide useful functionality to consumers. And we're seeing that expand into other areas of finance and energy. In the EU as well, we have obviously a digital package of regulation. As part of that, there are these concepts of data trusts, and we've seen one for sustainability, one for healthcare. And that is a place where data can be stored and made available to innovative applications, including using quantum and AI to help further social outcomes. But essentially what we'll probably see with these open data, smart data frameworks is flows of data that are structured based on consumer consent, allowing perhaps disruption to traditional brand loyalties or data sets. So your organization might be reliant on people coming back because you hold a certain data set, but this may be subject to some disruption.
Yeah. Sorry, go on.
Yeah, I think, no, it's fascinating. And I think I wonder how that will, what businesses might do about all of this, where they should start, because I realize we've covered a lot of topics today.
Yes. I think it's going to be require businesses to take action. And I think that is really our takeaway from this session that we're doing. It's really important that there is a quantum risk management plan that businesses will actually understand and have an inventory in terms of what are the systems that they are using, also in terms of planning, whether it's migration, types of encryption, how they're going to manage their data, and that's very important to have that strategy also in terms of the data, because as you mentioned, there is existing data that they may or may not wish to retain. There is data that smart data that they may want to use to their advantage as well. But it's really important that there is this risk management strategy. And I think that is a requirement now for senior management boards, etc., to really be on top of this. And of course, while there's all this risk and there's also the wonderful, future of this technology and the investment, what are the opportunities, right, that we can see? I mean, you've talked about how it can be used in all sorts of different technologies, navigation, mining, etc. It sounds really exciting. It's going to change a lot of what we understand today. And so I think that's, again, businesses need to look at those opportunities and to see how they can leverage the technology to their advantage, and make sure they don't get left behind. And I guess, in terms of, as always, we have to think about the supply chain. And so it'll be important to manage the supply chain and the risks in terms of quantum to the supply chain as well.
We have seen lots of policymakers also focusing on literacy and training. So investing in building up capability in PhD researchers, but also across the workforce and helping to accelerate skills. And that'll be something that boards will want to think about too. But I think initially, obviously it's early days. Lots of these technologies are still fragile and still coming to market. In the EU and UK, national quantum strategies have just been launched. They're still fairly new, so there's still this era of exploration. And I guess over years ahead, we're likely to see some real acceleration of deeper use cases for quantum technology, just as we are with AI. everything began at quite a high level with people using AI technologies just as a personal assistant. And now we're starting to see those deeper integrations of agentic AI. In the same way, quantum's effects will really differ depending on the type of business concerned. There'll probably be more of a hardware focus where we're talking about sensors, we're talking about networks, or maybe more powerful AI use cases that can accelerate what an organization's already doing. So it's just being agile, being ready, and learning about this technology increasingly.
Exactly. I think the takeaway is that quantum future is now. So it's time to really invest, educate, and strategize today.
Yeah, I completely agree with that. And I think, also just remaining familiar with the difference in geopolitical approach as well. So we're likely to see lots more investment from public sector in supporting grassroots innovation, growth of companies and maturing these technologies. So that's likely to be opportunities for funding and investment that organizations can explore.
Fantastic. Thanks, Lisa. And I think we've covered that topic. And hopefully the listeners will have enjoyed that session. Thank you very much for tuning into this podcast.
Thank you. It's been great to join you today.
I want to thank our guest for joining today's episode of GTWN Now, and give a big thank you to our sponsors, CMS Global, for making this episode possible. Today's podcast will be available on our website, gtwn.org, Apple Podcasts, Spotify, and wherever else you get your podcasts. Don't forget to hit the subscribe button so you'll be notified when new episodes drop. I'm your host, Rasali Gatau, GTWN International Board Member, wishing you a week of wonder.